Good morning, class. Most of you know me, but I'm introducing myself as Adrian Dietzel. I'm now taking a class. So we're doing, today we're doing the floor systems. So there's criteria in your Certificate 3 in Carpentry, and each criteria has different elements of each subject that we've got to learn. This one today I'm teaching you floor systems. Now, just for the presentation of the class for my assessment, this is what I'm teaching you today is actually usually run over a 5-day period in a college apprenticeship. So I'm crammed it into an hour and a half. So if you have any questions, please ask, put your hand up, and yeah, we'll have group discussions as we go through. But yeah, we're going to start with first, we need to start with housekeeping. So first to let you know, we've got the emergency doors, exits on that side there. As you've already had, you've got coffee, tea, water, anything you need from that side there. When you go through to the right, through the hallway, you've got amenities, toilets around the corner. Workplace health and safety, I've done a risk assessment, everything in the room is quite substantially safe. If in case of a fire, you've got the exit door straight through that way, straight out to where the entrance point you came through. Alright, so the whole learning objectives today is, so session 1, we've got 3 sessions. We've got session 1, session 2, session 3. Session 1 is going to be the basics of how floor systems work in the construction industry. Session 2 will be more details on how bearers and joists are installed. And then by session 3, we'll start learning the flooring, how the flooring gets put down, and then you've got your finished floors. So basically, understanding how floor systems work, understand the laws and regulations for the NCC and the workplace health and safety. So I will be going through all that with you guys, so from start to finish. Basically, read and interpret instructions, understanding the correct tools and PPE equipment used when installing these floor systems, bearers and joists. So basically, you've got your different types of flooring systems. So you've got your timber flooring, so that's your finished hardwood flooring, but generally, in the construction industry, we have our chipboard flooring, which I'll explain that later. The chipboard flooring is a structural tongue and groove type of flooring system, and then we end up putting a finished floor on top of it, which can consist of tiles, all different types of laminate, any type of finished floor. But essentially, we're going to be going through how the floor systems work, so how a bearer works, joists, and then the flooring goes straight on top. And that's the whole component of how it works. We're not talking about concrete slabs today, because that's another whole module in itself. So today is just essentially the framework of how, in the construction industry, when it comes to renovations, new homes, extensions, how this system works. So like I said, you've got concrete flooring, you've got tile flooring, you've got composite flooring. I'll explain a little bit more in session 3 of how each of those floor systems work. Now, before I go any further, in front of you, I've printed out all the slideshows that I'll be presenting on the screen as well. So if you want, you're more than welcome to go through that. Make any notes. If you've got any questions at the end of the class, we can have question time, feedback time. And I've also I need everyone to make sure they've written out the attendance record on the clipboard. I'll collect that after. And in front of you, later on after the 3 sessions, I've got an observation checklist and a feedback checklist of how my performance is today. But you can do that at the end of the 3 sessions. Basically, we're going to have first half an hour session, then we're going to have a 10-minute break, we're going to have a second session, 10-minute break, and third session, and then we complete the module. And then we can have, in the conclusion, we can go through questions and feedback. So, next we've got the components of the flooring system. So you've got your subfloor, which is your plywood, particle board, or concrete. So that's your main, as I was saying before, it's the main structural integrity of your flooring, and then you put you've got your other finished floor components on top. So, where we go? So under the National Codes, under the National Construction Code, all flooring that's provided has to be manufactured, installed by manufacturer in specifications. There's different types of flooring you've got to choose. When you start looking at a plan, which I'll show you soon, first off I was going to say, everything I'm explaining, it will all make sense very soon. I've just got to go through the process of the criteria. First, with the National Codes, Construction Code, everything has to be done according to engineering specifications, manufacturer specifications, plans, drawings, however we design these floors. They all correspond with the National Code. Everything has to be signed off by QBCC. So you've got QBCC there, then you've got Workhouse QBCC, which is the Building Construction Commission. They monitor and they do the insurance. So, for example, if someone installs the wrong type of flooring, a builder installs the wrong type of flooring, and basically you have cupping or you have a defect issue, the QBCC come in and they take over and they help rectify the situation. So that's how QBCC works. Most of you will probably know, doing the apprenticeship, you'll learn about QBCC. But yeah, we're all based on the National Construction Code. We have to make sure that we work with that system. And they have all regulations that are updated every year through HIA, which Housing Industry Association, and you've got Master Builders. So there are different companies that provide a lot of information in relation to different codes, different types of materials that come out every few years, you know, different trial and error of different types of subflooring. So first, we're going to look at what the correct tools we need to use. So most of you, being apprentices, have used the construction tools. So basically you've got your standard tape measure, you've got your cork glue gun, which that's for the flooring for the glue, which I'll show you later in the next few slides. Typically you've got your power saw, impact drill, level, drop saw and nail guns. So these are your main components of all your carpentry tools that should be in your toolbox, in your tool ute, that are used to start these type of construction in the flooring. So basically you've got your cutting tools, fastening tools and measuring tape and marking tape. So again, you would have learned that in carpentry certificate, in the carpentry module number 1, which is tools and equipment. That's part of the carpentry, so we can skip that. Then you got in the health and safety under the carpentry criteria number 1 with health and safety. You would have learned most of this with the ear protection, head protection, eye protection, all that. Unfortunately, I'm not wearing any shoes today because I've got a really bad sore on my foot. So technically, I would be wearing shoes today, but unfortunately, I'm not. So just to let you know in advance. But yeah, most of the time you've got to wear your foot protection, steel cap shoes. You basically learnt all this in your criteria number 1. Now, types of flooring and installation. So this is how we start getting into a brief description. So you've probably seen this around. In here you've got your joists. So when you're typically building a new house, you have all your different joists through here. You've got your face beam and you've got what you call a bearer down here. So the bearer is the timber that's connected to the post. The joists sit on top of the bearer and then your floor goes straight on top. So I'll show you here. This is another example. So this was just the structure we were doing for the scout den. So this is the most basic, simple idea of how it works. You've got your posts that come up through there that are bolted to the bearer. The bearer spans across there, and then you've got your joists which distribute the load in between, and then your flooring goes straight on top. So these are the typical types of bearers and joists you see. As you can see, the bearer is connected to the post and all your joists, and then we learn later how the floor goes on top, the chipboard flooring, and that's the basic construction. That's how it works. So I'll show you a bit more in detail. So when we learn about planning, you don't need to know the full detail of what you're seeing here, but I'm just giving the example. When we look at a plan, so over time when you look at a plan, the engineer specifies the type of joists we need. You've got different sizing. So try to imagine this house here, we're looking at that direction there, which is a side elevation. So you've got your piers, which are your concrete pillars, then you've got your posts, you've got your bearer, and just like I showed you in the first photo, there's all your joists. So you can see they cross over, and then you have your flooring straight on top. That's the basic component of how it works with the plan system. Now if we go to the next one, that same house that I just showed you is now, we have a floor plan view. So that same house that I just showed you, this is just an example of one of the houses we did. You can see here, and you'll learn this more in plans and specification in certificate in the criteria number 4. So this is more just to give you an in-depth bit of an idea of how a plan works, but you will learn that further in your carpentry apprenticeship. So try to imagine the view that you had on that house there was that view there. Each circle, you'll see these are your footings, your posts. These bigger lines through here are the bearers, as I've shown you on the other photo, and then you've got your joists going that way. So the whole idea is the bearer spans. The bearers are always at quite size 240, 300. Yeah, they're quite sizable because it all depends on. So depends on the span of the footing. So sometimes they might turn and go, we don't want a row of those posts through there because we want to put a car under there. This is just an example. So this bearer would go from a 230 mil potentially to a 300 mil steel beam. So before you know it, you've got a steel beam going through here. So the whole idea is when the joists are sitting on top of these bearers, you've got load distribution on each bearer. So that's how they indicate, that comes back to an engineer. Engineer specifies that, designs that, and again, like I said, say the owners of this house wanted to put cars under here, you'd alleviate them, but you would strengthen your bearer, and your joist would stay the same, but you're strengthening through the bearer support. Have I got everyone still on board? Okay. And yeah, that's your typical floor plan. So just to give you an idea, that's your living, your deck, bedroom, ensuite, and so forth. But when we go back to the simplicity of bearers and joists, you forget that plan, you just look at this one here and you understand how the bearers and joists work. So as I'll go further, so again, just to give you a basic example, like I showed you before, bearer always runs longer, then you've got your joists that sit on top of the bearer. The whole idea is, this is another example through here. So you've got your footing, your post, bearer, floor joist, and then your flooring goes straight on top. So that's the basic component of construction. These ones here, same deal here. You've got your post supports, bearer takes the support, and again, like I was showing you in the plan before, if we remove these two posts, this bearer would have to be engineered and it would have to substantially go bigger to withstand, because if we took these two posts out, this bearer would over time would deflect down and would start bowing, and that's not how it works. So once you understand the engineering of how the bearer supports the joists and the flooring on top, this one up here was just another example. This is one of the jobs we did. We have your joists up here. This was a bearer before we installed the steel plate. So what ended up happening was, it was an old house that was built 30 years ago, and what ended up happening was, this concrete post which is existing, this bearer, because of the 3-story house, this bearer actually started bowing down to the point that their bathroom dropped that much. So we had an engineer, we ended up jacking up the bearer and we ended up putting a steel beam through. So imagine, going back to this example, this house as an example, the bearer was not sufficient enough to take the weight of the house. So the bearer started deflecting down, and before you know it, when that deflects, all your joists drop, and next minute you've got in your floor, you've got dips everywhere through your whole property. So that just gives you an example of how important bearers are when it comes to the size of the bearer. But again, that comes back to the engineer. Engineers goes off by the National Construction Code, and then we make sure we put in exactly what the engineer asks. Sometimes we can always upgrade it. Sometimes we can talk to the engineer and change it if we need to as well. But once you start learning the basics of bearer, joist, same scenario on there. So here's another example of, so again, we're going to cover this more in session 2 and session 3, but again, I just want to give you the basics of what we're learning. So again, same scenario, this is your chipboard flooring, then you've got your bearers, and then you've got your joists. Some joists are made out of solid timber, some joists are I-joists. These are manufactured and engineered specifically for different spans, so you've got all different sizes. Again, that all comes back to the engineer. The engineer decides on what size, so he'll look at a house plan like this and go, okay, these joists have to be 200 mil. So again, in this scenario here, you can see here, the way they've done the bearer through here, you've got boots, which I'll explain more. This obviously had to be engineered, so each joist had to be connected to these with the boots, and you can see the size of that bearer. Again, the engineer designs. So again, we go back to that plan that I showed you. We just have to make sure we go off what the plan states. So engineer will always have a specification list of what has to be installed. Again, another scenario which I'll show you in session 3. The way we install the chipboard is glue. As you can see here, we've got a glue and we've got to nail it down. The whole idea of the glue, theoretically the nails are actually holding the floor down for the glue to dry. Once it's all tongue and grooved together, sometimes you'll find if it's not glued correctly, you probably experienced this in some old houses where you walk through and you can hear a crackle somewhere, creaking. Sometimes it just means that the glue's either detached from this floorboard itself, or they haven't put enough glue behind there. So it's quite important to, when you're doing your flooring and your floor sheets, it's very important to put all your glue down as much as you can. So more glue is better than less. So, and yeah, so far in the conclusion, this is just the basics of how floors work, the bearers and joists. Session 2 will be more in depth of how the bearers and joists work, how we fix them and how we install them properly. Again, like I said, when you go back to your first photo that I showed you before, you can see, again, this is a double story they've built. They've got the frame there and they've got a bearer at the end, and each joist is connected. So the whole component of flooring tongue and groove, like I said, bearers and joists, bearers one length one way and joists go the opposite direction. Any questions? Jason?
You mentioned about QBCC. Is there different things for different states?
Yes, there is. Yes, so you've got Queensland Construction Commission, Sydney. You have, off the top of my head, I'm not sure 100% what company they are, but you've got each regulated state authority. So I've only worked in Queensland, so I'm only worked with QBCC. But yeah, at the end of the day, each state has their own governing authority, and some of them actually have their own different building techniques too. So, for example, when you go to New South Wales, in Queensland, we scribe all our roof. If scribing means where you've got your ridge cap, and you know how you got the corrugation, and you can scribe, you know, you cut the ridge cap to a corrugation. In New South Wales, their regulations are different. You don't need to scribe. So most of the flashings just go straight on top. So that's just an example. In their engineering specification, which will be in session 2 and 3. So session 2 and 3 are going to be a bit longer than session 1, but example is so when you've got your chipboard flooring, which I'll explain more, you've got 3 different types of chipboard flooring. You've got your yellow tongue, red tongue and green tongue. Yellow tongue is very standard, and that's the chipboard flooring. Yellow tongue is very standard, but it doesn't withstand moisture as well. Then you've got your green tongue, which I've used on most of my jobs. Green tongue is, all it is the colour coded is the tongue and groove. You'll see, which I'll show you, inside the joint they'll show you the different colours. Yellow is standard. Yellow is a standard, what do you call it? Actually, I'll write on the board here. So when you've got your yellow tongue, you've got your yellow tongue, which will be, so when you've got your joist through here, each joist has to be a certain measurement in between. So there you've got your bearer going this way. As I showed you, this is the joist looking this way, and then your flooring goes on top. These measurements for yellow tongue and green tongue, 450 centres. So 450 mil between the inside of that one to the outside of that one. That is what engineers specify, 450 centres. Again, yellow tongue, when you got your joints through here, I found over time, when you've got your floor joints, when you've got your joins, over time with yellow tongue was when you're building a construction site, when you're building a house, you know, you might have weather issues where all of a sudden it'll start raining. You know, it'll start raining, and for about a couple of weeks you've got an exposed floor to the elements of the rain. What I've found over time is the flooring ends up, you've got your join there, then you get join here, your flooring ends up cupping. So what ends up happening is the yellow tongue starts cupping at every joint. Green tongue, which I've explained, that's another type of flooring, which is a little bit more expensive, but I've used it on most of my jobs. Green tongue is specially treated for moisture. So what ends up happening is you don't get any of this cupping in the flooring. So imagine the cupping will go like that, where the joint is. And then what ends up happening is on yellow tongue, once we get to a point where we've got the roof on and we want to put our finished floor, which I'll explain, you most likely have to sand most of those joints down, and it gets to a point that you're spending nearly 2 days sanding it down. Having green tongue flooring, it's all moisture preventative. You occasionally have to sand the joints, but nowhere near as excessive as that. Now, the third one you'll learn is you've got your blue tongue or your red tongue. So you know how I explained you've got your 450 centres over here. On a red tongue or a blue tongue, with your blue tongue flooring, your centre can go up to 600 mil. So red tongue and blue tongue is specifically an engineered design to span a lot wider joists. So again, so if we go back to the house plan here, so try to imagine you've got your bearers going this way, and say the builder who's doing the building at the time, say I decide to go, okay, I want to do less joists, but then what I'll have to do is I have to make sure I use blue tongue or red tongue flooring. So these joists here, if you count all them, there's probably about 18 joists there, but if you end up using red tongue or blue tongue, which is double the price of green tongue, technically it's worth going the green tongue or the yellow tongue. But sometimes there might be a house design where they might have coffered ceilings, or they might end up wanting to bulkhead or do engineering or anything that needs to be finished underneath the house. There might be a reason why they have wider span in their joists. So they might have 600mm joists. So if that's the case, then you've got to go make sure that you look at the manufacturer specification and make sure that you choose red tongue or blue tongue. So that's, again, that just gives you the idea of how do you understand the joist work. And again, the bearers have to be bolted, which will be in session 2. Bearers have to be bolted to each post support. So as you can see in the next one here, like I was showing you again, try to imagine where you have your posts. These posts can be either timber or steel. Most of the time we use steel because we end up using a bracket. Yeah, so just to give you an idea. So the whole idea is you start from the ground, then you've got your post, which is your post supports. Always, again, it's just another observation, when you do your post concrete, always do a mount on it, so that way you keep all the water off. I've seen some jobs where they have it flat, so what ends up happening is the steel post ends up rusting in the corners. So you always try to mount your post up. Then you'll have a steel post that'll stop there, and then you'll have a welded bracket. So this is looking at the side view of how this works. Your welded bracket on here, then your bearer will go straight on top of the steel post, then you'll bolt through. That's how the bearer works. And then you've got your joist that goes straight on top. So obviously you'll have other posts here, another post here. That's how your joist spans. Again, we go off how the engineer's requirements. And then your flooring straight on top of the joist. So that just gives you a very basic indication of how post, bearer, joist, flooring on all structural houses. But each, again, it all comes down to the engineer. Engineers, when they provide, so sometimes when I've had an engineer provide a plan to me, sometimes you can look at it and go, okay, I don't want to use, so these ones here, this one, that's from one of my jobs, this is not from one of my jobs, but these are what you call screw piers. And the screw pier is, so there's two different ways of doing this. When you concrete your post in, what we've done in the past is we'll concrete a post in and say we go, okay, the height of the post cut, so we get the height of the house, measure down from the floor level down. We obviously count to say this is 200mm joist. You've got your 20mm flooring, and then say that's technically 300. So you go 3, 4, 5, 520. So once you get your heights, so once you know with a laser, you know what your floor height is, finished floor height, you measure down, and that's how you cut the post. Now, when we've done concreting, we'll actually put a post and we'll have it stick up past a height, about 200 to 300mm. The next day we go through the laser, we cut them off all level, and then we weld a steel bracket on. That's more of an efficient way of doing it, but there are other builders who use these screw piers. So what ends up happening in that scenario, which you'll probably find on some of your jobs, is when they concrete your post in, they'll concrete the post in with the screw pier and the bracket, so that screw pier can adjust its height up to 300mm. They'll concrete all these with a string line, so over time, when that concrete post drops, you might find that when this post is in, this screw pier is in, if you put a string line, you might find one post will be lower than the other post. So the whole idea of screw pier brackets is to adjust them. So once these are all concreted, all you have to do is adjust it. But in my opinion, the best way to go is you just concrete your post in, have it sticking up 2 to 500mm, go through the laser, cut it off, weld the bracket, and that gives you a perfect line. So when you go back to here, so imagine all these posts, when we concrete them in, they'll all be multiple different heights, but we've got to make sure we stay above this cutting line, because the last thing you want is to put a post in and the post is shorter than the cutting line, so next minute you have to weld a block of timber on there, and that's just terrible, so you don't want to do that. So imagine each post is concreted, next day you go through, cut them off, weld the plate, and you know you're spot on with your heights. But again, like I was showing you on the other slide there, that one there with the screw piers, again as I was explaining, a lot of builders use the screw piers, but I found that they're a lot more expensive and a bit tacky. Because when you eye it through, you might find, as you can see here, one thread might be shorter, one will be longer, and before you know it, all your posts end up looking wavy. So yeah, that's basically your posts. That's the explanation of the posts, bearers and joists. So again, on the next session, we're going to learn more about how these bearers work and different types of bearers on each type of house, and how the joists are installed and what we use to install the joists and install the bearers. And again, session 3 will be more in depth about how the flooring works and so forth. So we've got a couple of minutes. Any questions? Yes, Mum?
Why do we have squeaky floor? What causes the squeaky floor in the timber floor?
As I said, so when you go back to, so here, as I was explaining before, gluing your floor down onto your joists. So old mate here, if he's gluing the floor, there might be a couple of spots where you've either got moisture on the joist. Some days when you do flooring, it's always first thing in the morning, so there's moisture everywhere. There might be a point where he might glue and the glue peels off. So as the floor goes down, when they nail the floor, you'll find there might be a little gap there where the glue hasn't taken to the floor, and that's where you walk through and you hear the creaking and squeakiness in the floors.
Thank you.
Adrian, it may be covered in the next session, but what's the glue they're using?
You've got all different types. You've got polyurethane, liquid nails, but I'll cover that in the next session. So you've got different types of glue. Polyurethane is a good one because when you've got, so most of the time I use polyurethane or liquid nails. It depends on the season as well. So during your wet seasons, I'll use polyurethane because polyurethane is a compound that sticks to the moisture really well. So if I use the polyurethane glue gun, it'll actually stick. So say the joist had a bit of moisture on it, it'll stick a lot better than liquid nails. But when it's a hot summer day, liquid nails is the best way to go. Polyurethane's double the price of liquid nails. So it depends on how but it all comes down to season too.
Thank you.
All right.
Okay.
We'll have a 10-minute break. We've got coffee, food, and yeah, we'll get into the second session. More detail. The next two will be more outlined and more in depth. And
So we'll be able to build a home.
no, you'll be able to install the floor.